Okay, on these problems, we're going to determine the inverse Laplace transform of the given function. So our first function has g of s equals e to the negative 3s divided by s minus 2 squared. Now, the formula that I'm going to focus on is if the right-hand side says e to the negative as fs. So let me rewrite this. G of s equals e to the negative 3s fs. All right. So in this case, e to the negative 3s will take the place of e to the negative as. So a is 3. Now, if I have that, and this would imply that f of s is equal to 1 over s minus 2 squared. Now, the inverse Laplace transform of this expression here, this function here, is, according to our formula, the unit step function u of a f of t minus a. So that's plugging in, we'll get u3t f of t minus 3. So there we go, except we need to find what f of t is so that we can use this formula. So now I'm going to focus on this shift. I have s minus 2. All right, now how do I end up with a shift over here on the in the s domain? How do I get that? Well, Laplace transform of e to the at times a function is the shift of the Laplace transform. So in this case, I have minus a, here's a here, so I'll e to the 2t. Laplace transform e to the 2t times a function will give us that shift, s minus 2. But what also I need to look at is the formulas that the Laplace transform of t makes 1 over s squared. So it's Laplace transform of t times t makes 1 over s minus 2 squared. You could have that actually as just another formula, that Laplace transform e to the at times t is equal to 1 over s minus a squared. I think it's some charts you'll see that. So what does this imply? This implies that our little f of t is equal to e to the 2t times t. So therefore g of t, using what we have, what we've discovered here, is equal to u3t f of t minus 3. So we have to replace t by t minus 3. It's definitely a lot going on here. Definitely, I can see why you might just want to have a computer do all of this for us. Okay, let's go on to the next one. So I'll use the same idea as that h of s is equal to e to the negative 2s times f of capital F of s, where capital F of s is equal to 1 over s squared plus 2s plus 5. If this is the case, then the inverse Laplace transform is u2t f t minus 2, according to our formula up here. So we need to find f of t. Well, we can write f of s is equal to 1 over, okay, what? This guy over here is a polynomial that does not factor over the real numbers. It's irreducible. What we can do is we can complete the square. So we have s squared plus 2s. We take 2 divided by 2 and square it and get 1. Subtract 1 plus 5, or you take 1 away from the 5. And then you get 1 over s plus 1 squared plus 4. 4 is 2 squared. Okay, so maybe even better would be to write this as s plus 1 squared plus 2 squared. And then what I do is in the numerator, I multiply by 2 in the numerator, and then I divide by 2. Why am I going to do that? Because we have yet another formula that we're going to use. The Laplace transform of sine bt is equal to b over s squared plus b squared. And so therefore the Laplace transform using this guy up here, if I use this up here, Laplace transform of e to the at sine bt is equal to b s minus a squared plus b squared. I think it's worth it just to put that as a formula instead of having to work through all this stuff. So therefore, Laplace transform of, all right, what am I going to use for, if I have s plus 1, but I want to put that as s minus a. So I'm going to put e to the negative t sine, I have 2 squared b squared, so it's sine 2t, will equal, oh, we had 1/2 also. Let's put the 1/2. 1/2 2 s plus 1 squared plus 2 squared. So f of t apparently is 1/2 e to the negative t sine 2t. So going over here, h of t is u2t 1/2 e to the negative t minus 2. So we replace t by t minus 2 sine of 2 t minus 2. Okay, did that one. These are not that easy, are they? Sort of difficult. Okay, let's go on to this next one here. This one does not, this one's a little easier, actually. Well, maybe not entirely easier, but a little bit. This does not have this exponential part, so we'll give ourselves a little break on that. Let's see if it's easier. So in this problem, what we're going to do is we're going to use a partial fraction expansion. So we have 2s minus 5 over s minus 1, s minus 2 equals a over s minus 1 plus b over s minus 2. And we clear the fraction. And so probably the most direct way, or easier, I would say, is put in numbers that are convenient. If I put in s equals 1, 1 minus 1 makes 0. So we get 2 times 1 minus 5 equals a, 1 minus 2 plus b times 0. So this gives negative 3 equals negative a, so a equals 3. And looks like I'm going to run out of room if I don't be careful, if I'm not careful. The next easy, convenient number would be put in s as 2. 2 minus 2 is 0. So for s equals 2, I'll have 2 times 2 minus 5 equals a, 2 minus 2 plus b, 2 minus 1, negative 1 equals negative b, equals positive b. So b equals negative 1. So apparently k of s is equal to this expression here, a over s minus 1 plus b over s minus 2. But we found a and b, so it's going to be 3 over s minus 1 minus b over s minus 2, so it's, or plus b over s minus 2, so it's minus 1 over s minus 2. And then we use the Laplace transform of e to the at is equal to 1 over s minus a. So little k of t, therefore, is equal to 3 over, or it's equal to 3 e to the t minus e to the 2t. All right, so I'll just zoom out. We can look at all this stuff here.